Hello, everyone. Welcome to Virtual Memory Topic.
Hi, what are you doing?
Playing this GTA 5 game on my computer.
Wow, nice game. It is fascinating. Can you give me that game in my pen drive?
Yes, sure.
How much size it is?
Approx 100 GB, perhaps?
Then how is it running? You do have only 8 GB RAM? How RAM will load such a big file to our computer?
I too don't know. Let's search in Google.
You all will be thinking, how is this working, right? Yes, you are right. The answer lies in the concept of virtual memory. Virtual memory is a very crucial concept in operating systems. Let's dive into it and see its magic. First, let's start by understanding the basics. In a computer system, the physical RAM acts as primary memory, where data and instructions are stored for fast access. However, physical RAM is limited in size. That's where virtual memory steps in. Virtual memory is a memory management technique used by operating systems to provide an illusion of having more physical memory than actually available. It allows us to run more programs simultaneously and efficiently. Virtual memory expands the available memory by using secondary storage devices such as the hard disk. Virtual memory is implemented using demand paging. The process of loading the page into memory on demand, whenever page fault occurs, is known as demand paging. Example, when you are in the GTA 5 game, only the associated map and other required features gets loaded into RAM, whereas Avatar Changing Program is not loaded. Similarly, when the user wants to change the avatar in the game, program containing avatar changing feature is loaded into RAM, and other programs such as Game Map is removed. When a program is running, it requires memory to store instructions and data. The operating system divides this memory into fixed-size chunks called pages. Similarly, when the user wants to change the avatar in the game, program containing avatar changing feature is loaded into RAM, and other programs such as Game Map is removed. This process is known as paging. The operating system keeps track of which pages are currently in the physical RAM and which are stored in secondary storage using a table. Each page has a corresponding entry in the table, which contains the frame number where the page is stored in physical memory. When the program needs to access a page that is currently in secondary storage, the operating system swaps it back into the physical RAM, making space by moving other pages out if necessary. This dynamic swapping allows programs to utilize more memory than physically available. But wait, how does the operating system know which pages to swap? That's where virtual memory management algorithms come into play. These algorithms decide which pages should be moved in and out of the physical RAM, aiming to optimize performance. There are various page replacement algorithms like LRU, least recently used, FIFO, first in, first out, and optimal. LRU replaces the least recently used page, while FIFO replaces the oldest page. Optimal, on the other hand, replaces the page that won't be used for the longest duration. By selecting the right page to replace, these algorithms minimize the number of page faults, which occur when a requested page is not in memory. This way, virtual memory improves overall system performance. Now let's see the advantages and disadvantages of virtual memory. First, the disadvantages of virtual memory are: 1. The system becomes slower since swapping takes time. 2. It takes more time in switching between applications. 3. The user will have the lesser hard disk space for its use. Now the advantages of virtual memory are: 1. The degree of multi-programming will be increased. 2. User can run large application with less real RAM. 3. There is no need to buy more memory RAM. Now the question arises, why not to use virtual memory all the time? Virtual memory is an amazing tool that helps people get more out of limited memory resources on their computers, so why not use it all the time? Or even dedicate an entire hard drive for virtual memory. There are 2 big reasons that virtual memory shouldn't be the default substitute for RAM. First, it takes more time to read and write data on a hard drive than it does on RAM. The more your computer relies on virtual memory, the slower your programs will run, and the less you'll be able to effectively run multiple programs at once. Second, swapping data between virtual memory and RAM takes time. If the OS spends too much time swapping data between RAM and virtual memory, it can lead to thrashing, a severe drop in performance because too many computer resources are being dedicated to managing virtual memory and updating the paging file. So this is how it works. It was really interesting. I think you all got the concept of virtual memory. Thank you.